right, guys. We're going to be starting chapter 5. This technically comes from section 4-2. Like, remember, we just took chapter 4 test, right? So, thank you. All right, so this actually is section 4-2 from the chapter we just finished, but we actually did not do 4-1, 4-2, or 4-3 from chapter 4. Okay, we only focus on solving with the 4 methods. So before we get into chapter 5, we need to talk about a little bit of graphing. So today, I know, don't make that face. It's not that bad, I promise. So we're going to graph by hand today, just so you can kind of see how things work. And then we're going to graduate into the graphing calculators and use them instead. Okay? So graphing calculators are coming. We are graphing by hand just for a little bit because I think it's important for you to see where the different parts and pieces come from. That way when you're graphing in your calculator and you get something funky, you can kind of think back through like, wait a minute, if I did it by hand, where should it be? And like try to fix your graph on there. Okay? So I'm going to reason to my madness, I promise. It won't be bad. But I do have Angry Birds up here. I know some of you were very excited about Angry Birds. Why would I talk about Angry Birds, though? There's a reason for that. No, because graphing makes him angry. We're going to talk about quadratic functions, right? Everything we solved in chapter 4, everything was quadratic. It was an x squared. So we're going to graph them today by hand. If a Angry Bird, when they fly through the air, that's quadratic. Okay, that's why I have Angry Birds on there. So first, let's kind of talk through standard form is what? You guys should know standard form. Close. AX squared, yeah. So we're talking graphing, so everything's going to be y equals, right? Anytime you graph something, it's y equals and the rest of the equation. So it's going to be your AX squared plus BX plus C. Right? Everything's always in that form? Yeah. How's what? The bird? Yeah, the shape that they're in. That's quadratic. Do you guys know what that's called? Starts with a P? Yeah, good. It's a parabola. It's not parabola, okay? I hate when people say, like, it's parabola. No, it's a parabola. That is how you spell it. But it's pronounced parabola, okay? But yeah, the flight path that those birds are taking as they're flying through the air, that is a parabola. That is quadratic. So the path of any object flying through the air can be described as, you could call it parabolic. That's like technically what it's called. But anything can be described as being a parabola shape. So I talk about, you know, your little brother, your little sister, right? If you grab them and chuck them through the air. Don't do that. But if you did, right? You got mad at him. We always talk about baby brother, right? Pick up baby brother and you chuck him through the air. What shape is he going to make as he flies? A parabola. So if you do this, Mom, Dad, I swear I was just looking at graphing parabolas. That's what we're working on in class right now. Just want to see the flight plan. Just want to see the shape that he's making. I'm going to calculate that right there. All right, but anything flying through the air, though, can be described as parabolic or a parabola. Okay, so it's quadratic. All right, so real quick, let's just kind of go through the basics. Yeah, don't do that, though, okay? I know where you're coming from. No. All right, so number 1, put it in standard form and tell me A, B, and C. We should know how to do this, right? So for number 1, standard form, what order should it be in? Two x squared. We're just rewriting, guys. 2x squared plus x minus 11. Right? What's the A value? The B? C? All right, we did a lot of this in the last chapter, right? Quadratic formula. We had to make sure it was in the right order. Some of you did mess up a little bit on the test, which I'm almost done grading. But the test, some of you flip-flopped your A and your B or your B and your C, and then it messed up everything. You took a test last Wednesday. Sorry. So I was hoping to have those done and ready for you today, but I'm close. I'm on the back page, so I'm close. Number 2, what order should that be in? negative 7x squared plus 6x. What's your A? Your B? Your C? Good. If it's not there, it's just 0. And then number 3? It's already in the right order. Yeah, that's just the one part. So what's your A? B? C? Like a problem like that makes my math easy. All right, so before we get into all the new stuff, is there questions there? All right. So the point where the parabola changes direction is called the what, right? So it's going to go up. It's going to hit a point where it's not going up anymore, right? And it's going to start coming down. Do you know what it's called? Yes. It is called the vertex. I'm sorry. Just right next to it. Sorry. I never know how those things print. Because it looks pretty on my board. To be perfectly honest with you. That would cost a lot. All right. It opens which direction if the A value is positive? Yeah, it would open up. And has a blank point or value. It has a minimum. We've established that. I'm sorry. Right off to the side. Sorry, my bad. All right, so in other words, guys, if you look down here, we have y equals x squared. Now, one thing I do want you to know the name of, just so you're aware of it, this is called a parent function. Parent, like a mom, a dad, parent function. Isn't it funny how everything comes back to family, right? We had your little baby brother. It's a parent function. It's like mom or dad. We'll see if we can get that in. All right, parent function, though, is just like the most boring plain Jane quadratic you can get, right? It's just y equals x squared. There's no bx, there's no c, there's no a value other than 1. It's just very boring. But what's the a value on this one? A equals 1. That means it's positive, right? This is the shape it's going to make. It is going to be pointing up, right? It points upwards, so that means it's positive. It's pointing up. So when it says here, if it opens up, if A is positive, it's going to point up and has a minimum point value, meaning this right here, your vertex, that's the lowest point on the graph. It's the minimum value. Okay, so it opens down if A is negative, right? My A here is -1. Yes. And then now my vertex is the highest point, which is the maximum. So you got to stop and think what that graph looks like to think about if it's a minimum or a maximum, that value. One place where like this kind of thing is used, and people always wonder in the real world, when do we actually use math, right? This is one of those things that to me is the most useful, is looking at graphs. If you're like a business owner and you're trying to look at your projected like revenue, how much money you're going to make, if you graph things like that, filling in all your data, you're going to get a graph typically that is like a parabola. And what you would look at, that vertex, that point right there would be your maximum profit margin. It would tell you the maximum amount of money you could make. Okay, so this kind of data is very useful when you're talking about profit margins. All right, decide whether the parabola will open up or down and whether it will have a maximum or a minimum point. Okay, so the first one, it's going to open up or down. It's going to open up because your A value is 2. It's positive, so it's going to open up. It's going to look like this. Will it have a maximum or a minimum point? Minimum, right there. Right? It's going to be the lowest point. My vertex is the lowest point, so it's going to be the minimum. What? Good. All right, what about number 5? What's your A value? Good, this one's not written in the right order. A is 2, so it opens up because that was positive. And it's going to have a minimum. Oops, I never drew it. Don't mind my curved line there. right? So it's going to have a minimum point. It's going to have a lowest point on there. All right, number 6. What's your A value? Good. A is -6 right here. So it's negative. So it will open down. And that's going to have a maximum point. Right? The highest point on the graph. How are we feeling? Pretty easy? Whether A is positive or negative tells you it opens up or down. Okay, so here we go. Now we're into the nitty-gritty stuff. So first thing we need to figure out is we have to find the vertex. So if I'm asking you to graph these by hand, you could, in theory, make an XY table and plug in points till you're blue in the face and see if you can find it to make the right shape. You could, but you know me, right? Lazy. I don't want to do all that. So for me, I'm going to figure out exactly where that turning point is, right, the vertex. And then I'm going to know, I can find points on both sides, and I can know exactly where it's at. So first thing we have to find is the x-coordinate of the vertex, which is at -b/2a. Write that down. You need to know this. The x-coordinate is at -b/2a. Does that look familiar? That's part of your quadratic formula. Yeah. You took off the discriminant part, right? The radical. So -b/2a is going to give you where the x value is of that coordinate. And then we're going to find that, and then you plug it back in to the equation to find the y value. So let's do this. It's okay. It's not that bad. It's not that bad. So first thing, -b/2a. So negative, what's my b value up here? 8/2 times a. Right, there's my a value. There was my b value. So then I get -8/4, which is -2. So you have found the x value of the ordered pair where that vertex is located, right? Because that vertex is a point, right? It's got an xy coordinate to it. So you found the x value. And then how do I figure out what the other part is? We plug it back in. So I'm going right back up to here. So I'm going to grab your calculator. I'm going to do 2 times -2 squared plus 8 times -2 plus 5. -3? She's fast. You guys confirm? Yeah, -3. Thank you. So my vertex then would be at -2, -3. We took the x value that we found here, and I literally just plugged it back in anywhere I saw an x. Yep, I just literally plugged it right back in. Say that again. Okay. All right, and we're going to do this a lot today. We're going to get practice doing this. All right, so first let's just practice finding the vertex a few times, and then we'll get into the actual graphing of it. Okay, so let's do number 7 together. Finding the vertex. Again, this is -b/2a, then plug back in. That's how we're finding this. All right, so negative, what's my b value? Over 2 times, what's my a? So that gives me -4/4, which is -1. So that's going to be my x value of my vertex. Okay, and then we take that and we're going to plug it back in. So 2 times -1 squared plus 4 times -1 minus 7. I'm literally plugging it back in here. It's going to give me -4. Yes. And again, guys, please practice typing these in your calculator. Izzy, maybe slow down a beat for us. But like, let everyone practice that. Because if you type something in wrong, you're going to get the wrong answers. Okay, no, you're fine. You're just excited. I know how exciting math can be, and you just want to do it, right? All right, so number 8. So -b. What's -b? It'd be a +6, right? Because technically it's negative, and then that's -6, which is just positive 6, over 2 times A. So we get 6 over 2, which is 3. You okay? Yeah. All right, and then how do I find the other part? Plug it in. So 3 squared minus 6 times 3 plus 5, negative 4. So that vertex will be located at 3, negative 4. We will practice graphing, yeah. But if we can't find the vertex, you can't do the other part. So we'll make sure we're good here first. All right, what about number 3? What's the b value? It's 0. Okay, so 0 over 2 times A. So 0 divided by 6 is 0. So can you do it if the b value is not there? Yep, it's going to be 0. All right, and then how do I figure out the y value? Plug it in. So 3 times 0 squared minus 4 is negative 4. I want you guys to try number 10 on your own. All right, let's try this, guys. Let's see how we did. So first part is negative b. What's my b value? Yeah, my b value is the negative 3. So negative 3 is positive 3 over 2 times a. What's a? Negative 1. It's over here. So that's going to be 3 over negative 2, which does not simplify. Okay. So in order to figure out this problem then, we're just going to plug this back into that. So 1 minus 3 times negative 3 over 2 minus negative 3 over 2 squared. Okay, if you rewrote it, totally fine. I'm just being lazy and not rewriting it. So as you're typing this in, be careful. Some people have a tendency to lose the negatives that are already like in the problem. Don't lose those, okay? So 1 minus 3 times negative 3 over 2 minus negative 3 over 2 squared. Got an error? Now, in that calculator, did you put the negative on the 3 or did you put the negative on the 2? You did put it up on the top? Okay. Okay, good, because that calculator doesn't like a negative on the bottom. Try typing it in again. Put the parentheses where you see them. You should get 13/4. Yeah, if you mess one sign up, the whole thing falls apart. 13/4? Or was that 3 1/4? Fine. Now, guys, let's talk about something real quick here. Up to this point, we have always preferred them to look like that, right? Because it's just easier to deal with mentally. If you're graphing, where's 13/4? That's just part of your point. That's your extra y. It'd be 3 1/4, 3 1/4. So if I was actually graphing this, I would switch that to 3 1/4, and I would need to switch this to negative 1 1/2. Now do you know how to graph it? If you would plot that point, you would go, your x value, you'd go back 1 1/2 and then up 3 1/4, right? So if you're graphing, you'd actually need them to be mixed numbers, because that way you know where they're at. Because otherwise, I'm like, yeah, 13/4. You're like, I don't know where that's at. Okay? Graphing then makes more sense for them to be mixed numbers. So let's actually practice graphing. Okay? First, let's just start, and I noticed your notes printed funny. Sorry. The software that I use to do all my notes in updated, and with the new update, suddenly it doesn't print tables. It'll print like the very first thing in your first cell, because I think you all have an X on your paper, don't you? But you don't have the rest. Sorry. They're working on a fix, they said. I don't think so. Nope. Thanks. All right, so sorry about that. So just go ahead and finish filling in your XY table there. That's not a hard one to fill in for you guys. Your table didn't print. When my software updated, it came with a glitch. Wasn't that nice of it? I haven't noticed anything be better since it updated, just that my tables don't print. All right, anyway, this is called your parent function, right? It's the most simple, basic one. And we know what it should look like, right? I already put a graph on your paper at some point. So let's go through the process for how this works. So do you guys remember XY tables back in the day? Yeah. Do you remember what numbers you typically plugged in? There it is. -2, -1, 0, 1, 2, right? You wanted to see the negatives and you wanted to see the positives. So let's go ahead and try this. So just like before, you have your x values. Let's plug them back in. So what is -2 squared? +4. -1 squared? 0 squared? 1 squared? 2 squared? Beautiful. Can we plot points? Let's plot some points. So -2, 4. -1, 1. 0, 0. 1, 1. And 2, 4. And then my favorite part is when I miss every point when I graph. Hey, I actually hit them all that time. I am terrible at drawing graphs on this board, just so you're aware. Ruler's not going to help you. Do not make them straight lines. Because are they straight? They are not. If you draw them straight, and I'm grading your graphs, and you have straight lines that are a V, wrong. Because they are not straight. Okay? So what do you notice about this graph? What's some words that you would use to describe this graph? It's positive. Has a minimum value. A word that starts with an S.
Sorry, first thing that came from my head. Yeah. Symmetric. That works too.
It is symmetric. It is symmetric. What's symmetric mean?
Same.
It's the same on both sides. What? Not the same as parallel. No, not the same as parallel. Okay, symmetric means, you guys remember, you may or may not have done this when you were a child, where you take a piece of paper and put paint on one side of it and you fold it in half and then you open it back up? You've never done that. You really should. It's fun, right? It makes it the same, right? It's a mirror image on the other side. It's exactly the same, right? So your vertex, wherever your vertex is, that's like your fold line, right? This is right down my axis, so you can't really see it. But that's like where they folded it so that one side is exactly the same as the other side. If you can picture the paint coming off like that. So that's like what your vertex is. That's like the line that's going to make this side is the same as this side. So me being a lazy mathematician, as you all know that I am, this is a lot of work. I don't want to do all that. Okay? As long as I know where my vertex is, because that way I know where it's the same on each side, right? As long as I would find like 2 points over here, could you reflect them on the other side? Mm-hmm. So my fold line, as you will, or it's called the axis of symmetry, this line that runs right through my vertex, I can see, like, if I craft this one first, that's one space away from that line. So this one must be one space away. This one is 2 spaces away, so I'd go 2 spaces on this side to get the other one. Right? They should be the same on either side of that line. So that's me being lazy, and let's do one that's a little harder than this one. Okay. Ooh. Ooh. All right. So again, finding the vertex, you do -b over 2a, and then plug that back in to find the y part, right? So we're not going to do that part here. Okay, so let's just go on to graphing this one. So I want you to graph y equals 2x squared minus 8x plus 6. Right away, do I know, is this going to open up or is it going to open down? It's going to open up, right? Because my a value is positive, so I know it should open up when I'm done. So first thing, step 1 is to find your vertex. So again, I'm going to do the -b over 2a. So what's -b? 8 over 2 times my a value. So that's going to give me 8 over 4 which is just 2. How do I find the y part? Plug it back in, so I'm doing 2 times 2 squared minus 8 times 2 plus 6. Thank you. Sorry, I did it in my head, and she confirmed my mental math. It's negative 2. All right, so can we plot 2, negative 2? That's my vertex. So 2, negative 2. Now, me personally, and this is up to you, if you don't have to if you don't want to, I always draw like a little dotted line where my vertex runs, because to me, that's my fold line. Yes, and it's a great thing to do. Okay, it's my habit. If I'm graphing, I automatically put that in. I'm not going to take points off if you don't, but it's easier because I'm lazy, right? If I'm going to plot points on one side and I want to reflect them, I'm going to need to make sure I know how many spaces away from what line I'm going from. All right, so there's my vertex, so that 2, negative 2. Now we're going to make an XY table. So how many numbers should I have to actually plug in? 2. Because that'll give me my vertex and 2 points on this side that I can then reflect and get 2 on this side. So I really only need to plug in 2. Now the question comes, what 2 points do I plug in? Technically, could I plug in anything I want? I could. If I plugged in a 10, would I get a point back? If I plugged in 100, do I get something back? What's my graph? My graph only goes from 10 to negative 10, right? As far as how big my graph is. So for me to have the best chance of getting things that fit on my graph, wherever your x value is here, I go 2 to the right. So that's at 2, so I'm going to plug in 3 and 4. Could you plug in anything you want? Sure, you could. But in order to try to get points, and that doesn't always happen, to try to get points that stay on the graph, I'm going to plug in 3 and 4. Okay? So plug in 3. So 2 times 3 squared minus 8 times 3 plus 6. Tell me what you get. 0? Okay. So we're good? 0? So I'm going to plot the point 3, 0. And then can you reflect that? It's 1 space away, so I'm going to go 1 space on the other side, and I can reflect. Then plug in 4. 2 times 4 squared minus 8 times 4 plus 6. She had 48 last time. Somebody want to confirm? 6? Okay. All right. So I'm going to plot 4, 6. And I'm like, oh, look, that's 2 spaces away from my line. I'm going to go 2 on the other side. And then you can draw it in. So what would I have gotten had I plugged in 1? You should get 0. Look at your graph. Since I reflected that, if you plug in a 1, you just typed it in. Did you get 0? Yeah. So I found that point without actually typing it and doing the math. Okay? Uh-oh. Yeah, you'll notice right away if your graph looks a little funky when you go to plot a point and you're like, that's supposed to open one way and I get like a W shape, like something's wrong, right? Yeah. Yeah, you're going to have to make sure you always start at the origin. Now, guys, let's talk about this because every year somebody messes this up. When you plot points from the origin, moving left, right, up, down. Right? The first number moves you left and right. The second number moves you up and down. But every year somebody's like, oh, do I start counting from the vertex? No, 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 no. We mark the vertex on our graph, but you start always plotting points is from the origin. Okay, always. Let's practice another one. Okay, so let's look at this one. Negative 4x squared plus 8x plus 2. So first thing, let's find our vertex. So we're doing the negative b over 2a. What's negative b? What's my a value? Negative 4. So that gives me negative 8 over negative 8, which is 1. How do I find the other part of the vertex? Plug that in to the original. So negative 4 times 1 squared plus 8 times 1 plus 2. Yes, it would be 6. Is there any questions on the vertex? You're right, it's going to open down. How did he know it's going to open down? It's negative. Yeah, so it's going to open down. But let's plot 1, 6. And again, me personally, I like my little dotted line. Helps me to see where that fold line is, right? Where that reflection happens. All right, and then we do an XY table. Now, my X value was 1. So what numbers do I plug in? 2 and 3. Again, you can plug in anything you want. But a lot of times, we're talking quadratic, so when you square a number, it gets big fast. So sometimes if you go too far away from that vertex, they jump way off the graph. Okay, so again, if I'm plugging in a 2, negative 4 times 2 squared plus 8 times 2 plus 2. Do you have to show me this work? No. But I found if I don't write it down, I get those kids going, where did that come from? So that's why I write it, just so you can't ask me that question. What did we get? 2. All right, so plot 2, 2. How many spaces from my fold line is it? So I have to go 1 space on the other side. I don't know. They didn't act like that on the last one we just did. I plotted the point 2, 2. Yes, right there. Over 2, up 2. From the, you always count from the origin. Plotting points is always from the origin, not from the vertex. Always from the origin. See, I told you, somebody. There's always one. Yes, I did. Yeah, plot your points from the origin. I did. Hey, at least you acknowledge that I did say it. Negative 10? Whew, I barely stayed on my graph. So do we panic if it does go off the graph? No, because things, they get big fast. That's right. So 3, negative 10. And then mirror it, right? It's 2 away from that fold line. I'm going to go 2 on the other side. That is why I draw that line. That way I can kind of count, okay, how many spaces over? I'm going to go that many on the other side. All right. Now I have more examples on there of just straight up graphing. Do we need that, or are you ready to move into the next part where we're still graphing, but then we're going to add something to it? Yes, we will. Tara? Yes. All right, guys. So now we're going to take and look at how is the graph related to the solutions or related to the answers, right? Because last chapter, our whole focus was, how do I solve these? Right? That was the entire focus the entire time, right? We were solving. We had 4 different methods to solve. So how is the graphing related to all of my answers? So first, let's graph it, and then we'll kind of go from there. All right, so if I'm going to graph this, what's the first thing we do? Find the vertex, right? That's the negative b over 2a. So what's my negative b? What's my a value? 1. So negative 2 over 2, which is negative 1. How do I find the y part? Plug it in. So negative 1 in parentheses squared plus 2 times negative 1 minus 8. It would be negative 9. All right, so that's my vertex. So let's plot our vertex at negative 1, negative 9. Again, I prefer to have my little dotted line. Okay, then we made an XY table. All right, this is at -1. I could go -2, -3, or I could go 0 and 1. To me, 0 and 1 just sound a little easier. But you absolutely could go -2, -3. All right, so plugging in a 0, again, it's going to be your 0 squared plus 2 times 0 minus 8. It's just -8, yep. So if I plot 0, -8, and reflect that, or mirror that, if you will, then we're going to plug in a 1. So 1 squared plus 2 times 1 minus 8 is -5. You tried some mental math? So plot 1, -5, and reflect that. Now, just to humor me, because I know what's coming, let's plug in another point. Plug in a 2. What do you get if you plug in a 2? So again, 2 squared plus 2 times 2 minus 8 gives you 0. All right, so 2, 0. And then reflect that. Normally, I don't make you do that many points, but I know where this is going, so I wanted you to see something, okay? All right, questions on the actual graphing? Well, let's take a look at the next part. So now let's set the function equal to 0 and solve using any method that you guys want. Okay, and let's kind of see what happens here. All right, so the equation, what did we have? X squared plus 2x minus 8 equals 0. What method do you want to do? We can do factoring. Could we do the square root method? No, there's a b term. Complete the square or quadratic formula. Factoring, does this factor? Yeah, let's try to factor this. That'd be the fastest way, right? So if I factor this, what are my signs? Options for A. So x and x. Then 1 and 8 or 2 and 4. Which one's negative? -2. Okay, so there it is factored. So then we set each factor equal to 0. Good, so x equals -4 and 2. Look at your graph. Do you see where the answers of x equals -4 and 2? How does that relate to the graph? Where did it cross the x-axis? At -4 and 2. Look, right here. That's -4. That's 2. Okay, so the question was how are they related to each other? Everything we did last chapter, how does that relate to the graphs of them? Where the graphs cross the x-axis is where your x values are. So instead of doing all that work of solving, you could graph it, see where it crosses, and that's your answer. Now, so right away you're like, oh man, that's pretty easy, right? But think of some of the answers that you got last chapter. Were all your answers nice and pretty? Some of them were imaginary. Some of them had radicals on them, right? Okay, so let's just kind of keep that in mind. Let's try a couple more here. Let's see what happens. All right, so let's try this one. So if you're going to graph it, so we need to do our -b over 2a. So yeah, 0 over 2 times 1 is just going to be 0. If you plug that back in, we get -5. So my vertex is at 0, negative 5. All right, and then you'd make an XY table. What would you plug in for X? Good. This is a 0, so I'd go 1 and 2. So if you plug in a 1, 1 squared minus 5, it's negative 4. Okay, so I'm going to plot 1, negative 4, and reflect it. If you plug in a 2, 2 squared minus 5 is negative 1. So 2, negative 1, and reflect it. Now, you see, I haven't actually crossed the axis yet, right? So let's try another one, because I want to make sure I'm seeing where it's crossing. So if I plug in a 3, that gives me 4. All right, and then we reflect on the other side. No, I mean, you can see mine has a curve, but it's not perfect. I mean, it's not perfect. Anything by hand is going to be imperfect. So does it cross the x-axis? Yes, but it's not pretty, right? It looks like it's somewhere between 2 and 3-ish, right? Okay, well, which method do you want to use to solve this? Let's solve it using one of our methods. Square root method, yeah, because there's no b term. So x squared minus 5 equals 0, right? If we're going to solve them, we just set them equal to 0. So I'm going to add 5 to the other side. And then what? Square root. So x equals plus or minus radical 5. Great. What's radical 5? Somebody tell me that. What's radical 5? 2.3 blah, 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 blah. Right? Blah, 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 blah. Okay. So it looks like it crossed somewhere between 2 and 3. Is radical 5 somewhere between 2 and 3? Uh-huh. Now we've always done plus or minus, right? Anytime you take the square root, plus or minus. Look at your answers. There's the negative 2.3 blah, blah, blah. There's the positive 2.3 blah, blah, blah. Kind of cool though, right? Like the graph crosses the x-axis at exactly what your answers are. That's kind of cool though, right? So is graphing to solve your answers, is that practical? It's not going to be exact, right? I'm like, it's somewhere between 2 and 3, but I'm not really sure. The reason we're even talking about this, because you're right, to look at that, you're like, I don't know, there's somewhere in there, but you don't recognize it. So the reason I teach this to you, though, in the next chapter, we are going to be solving not just quadratics that have 2 answers, but like x cubed, x to the 4th, x to the 5th, x to the 6th. So it's going to have a lot of answers, right? But if I can see the graph, and I'm like, oh, look, it crossed at nice, pretty answers for 3 of them, or 4 of them, could you then use those pretty answers to find the non-pretty ones? Okay, that's the point of it. The graphing calculator we'll use to find the pretty answers from the graph, and then we can find the not pretty ones on our own. So it'll save you a lot of time. I knew you'd be excited. Okay. Whoa, did I skip? No, I did. Okay. Homework tonight, you're going to have some where you're just graphing, and then you're going to have some where you're going to graph, and then you're going to solve, and we're going to make sure they match up. Because that's the whole point of this. Okay? The whole point is to recognize the answers are where the graph crosses. Okay? So the solutions to the quadratic equation are the points where the graph crosses the x-axis. These solutions, right, those are the answers, right? They're called x-intercepts because it's crossing the x-axis. It's intercepting the x-axis, right? The x-intercepts. They are known as the zeros Because what's the y value there? What's the y value where it crosses the x-axis? It's 0. So they're known as zeros, or the roots of the equation. So throughout chapter 5, typically they're referred to as the zeros. I will ask you to find the zeros of the function. So in other words, set it equal to 0 and solve it, right? It's going to find all the places where the y values are 0, and it finds your x answers. So I just wanted you to know the terminology, okay, as that comes upon you. If I ask for the x-intercepts, the zeros, or the roots, I'm just asking you to solve it. That's all I want. Now, let's take a look at this one. Don't die on me, guys. Stay awake. Or we're going to do jumping jacks here in a minute if we don't. Okay, so let's go through this one, and let's see what happens. All right, so let's find our vertex. So negative b over 2a. Good, so negative b is going to be a positive 8. 2 times 4. So 8 over 8, which is 1. To find the y, you plug it back in. So 4 times 1 squared minus 8 times 1 minus 5, negative 9. So 1, negative 9. Yeah, we can do 2 and 3. Is this the same problem we just did? Is it exactly the same problem we just did? That's it. It was very similar. For a minute there, I panicked. I'm like, wait a minute. Did I have a typo? I did not. Okay. So you're right. So this is a 1, so I'm going to plug in 2 and 3. Which direction is this opening? Up or down? It's going to open up? Okay. So if I plug in a 2, okay, so 2, negative 5, and reflect. If I plug in a 3, and then attempt to draw this whole thing in. Are my answers nice and pretty? Are my answers real? Because we've talked about real and we've talked about imaginary. So they're not pretty, but are they real? They're going to be real, okay, because they do cross the x-axis. All right, so if we want to go ahead then and solve this to find out exactly where those answers are, what method would you like to use? Use completing the square? That would work. It does. But it works. But I'm going to guess most of you probably would have went quadratic formula. Probably most would have. But completing the square absolutely works. So let's go quadratic formula, because that's where most of you want to go. Stop it. Well, you reflect across the axis, but you plot your points from the origin.
I'm trying to reflect off of
The y-axis.
Yeah.
Not the y. Well, that should be a red flag, though, right? That something's wrong. All right, so let's use quadratic formula. So negative b will be 8 plus or minus square root negative 8 squared 4 times 4 times negative 5 2 times 4. All right, so we get 8 plus or minus radical 144. Hey, if your discriminant is 144, that means that problem could have been factored. We could have factored it. That's all right. Okay, so what's the square root of 144? 8 plus or minus 12 over 8. They can all be divided by 4. So it'd be 2 plus or minus 3 over 2. What's 2 plus 3? So 5 over 2 is one of my answers. And then negative 1 over 2. So those are my two answers. What's 5 over 2? 2.5. So 2.5 and negative 1.5. That'll make more sense to us. So did it cross at negative half? Yep. And 2.5. So 2.5, yeah. My graph may not have been the most accurately drawn, but it is roughly in there, right? Okay. So that you could have factored that one. You may not have recognized it right away. But does it make sense how you solving, how it ties to the graph? Okay. 1 to go? 1 to go. We're almost done. You guys want to try this one on your own? No? Okay. All right. I'll do it with you. So vertex first, right? Whoa. Negative b over 2a. Good. 12 over 2 times negative 1. So 12 over negative 2, which is negative 6. How do you find the other part? Now, when you're plugging this in, guys, be very careful. Everybody look up here for a second, because I know this is going to mess people up. Do you see the negative sign right there? Leave the negative. Don't change it to a positive, because then you're squaring the negative 6 inside of there. Most students tend to forget that negative in the front, okay? So throw the negative, then you have your negative 6 squared, minus 12 times negative 6, minus 39. Holy smokes. Is that going to fit on my graph? What'd you get? Negative 3. All right, so negative 6, negative 3. All right. So if we make our xy table, positive 5 and 4, negative 5 and negative 4. That's where I would go to. So negative 5, negative 4. So if I plug in a negative 5, again, that negative is out in front, and then the negative 5 squared. Negative 4. You guys confirm? I'm trusting her. Okay. So again, you're counting these from your origin. So back 5, and then down 4, and reflect. Then if you plug in a negative 4, what do we get? We plug in negative 4. Negative what? 7. Thank you. So negative 4, negative 7. And reflect. Does that make sense that it opens down, or did we do something wrong? Okay, yeah, it was negative up top, right? Wait a minute. Say that again? They're imaginary. It doesn't cross the x-axis. That's where your imaginaries come from. Because normally you look at it like, oh yeah, where it crosses the x-axis, those are my answers. It doesn't cross. Yep, so that means this is going to have an I in it. So if you go to solve this, what method do you want to use? Quadratic, okay? So x equals negative b. It's going to be 12 plus or minus square root negative 12 squared minus 4 times a, which is negative 1, times c, which is negative 39, all over 2 times negative 1. There's a lot of negatives in that one. So what do we get underneath that radical? 12 plus or minus radical negative 12 over negative 2. Good. Pull your eye out. Pull your eye out, do your factor tree. So we should get 2i radical 3 over negative 2. Divide them all by 2. How about negative 2? I don't want to leave a negative on the bottom, right? So that's going to make that negative 6 plus or minus I radical 3 over, I don't really need it over anything. Does that make sense that I get an imaginary answer? Yeah, look at your graph. So this whole time you've probably been like, I don't really understand what imaginaries are. It's because it doesn't cross the x-axis. That's why imaginary numbers show up. The graph obviously exists, but the answers, it never crosses. Okay? Questions? Come on, kind of cool though, right? All that solving you did last chapter, how it ties to the graph, that's kind of cool. It all works together. Sure. I know you're not impressed.